Hey everyone, welcome to this explainer. Today we're going to completely demystify AQA powers and roots and literally level up your GCSE revision. No fluff here, just the exact step-by-step strategies you're going to need to completely conquer this section of the syllabus. So let's just dive right into a classic trap, one I see all the time. Can you explain why 5 to the power of -1 is absolutely not -5? Well, by the end of this guide, you're going to understand the hidden logic behind this, and more importantly, how to dodge this trap in your actual exam.
We're basically treating this explainer like a video game tutorial. We've got 5 levels to get through: the foundation, the indices laws, fractional and negative indices, surviving surds and irrationals, and finally, tactics for maximum marks.
All right, level 1, the powers and roots foundation. Okay, so first up, the base. This is the main, larger number we're dealing with, sitting right at the bottom of your calculation. It's exactly what it sounds like, the foundation holding everything else up. And right above that base, we've got the power, or the index, that small floating number to the top right. Powers or indices just mean repeated multiplication. So 5 to the power of 4, that's literally just 5 times 5 times 5 times 5. It's just a handy mathematical shorthand. One more quick term to lock in: integer. Keep this word in mind because it simply means a whole number. Things like 4, 17, or 203. It pops up constantly in these base problems, so when you see integer, just immediately think whole number. Moving right along to level 2, mastering the indices laws. Now this brilliantly illustrates a major pitfall. A lot of students see that multiplication sign and just automatically try to multiply the floating numbers. But think about it for a second. If you have 3 A's multiplied in a row, and then you multiply them by 4 more A's, well, you now have a chain of 7 A's. That's exactly why we add the powers. So the correct answer is A to the power of 7. So why do so many students get this wrong under pressure? Honestly, it usually comes down to panic or just a lack of rapid recall. But if you actually understand that indices are just a tally of how many times a base is multiplied, you completely bypass the trap of blindly memorizing lists of rules. Rules that, let's be honest, are super easy to mix up when the clock is ticking. You're doing great. Ready for the mini-boss? Here's level 3, fractional and negative indices.
I really want you to memorize this cheat code for your exams. Here's the golden rule for fractions in the power. The bottom number, the denominator, is always the root. The top number, the numerator, is the power. And what if there's a negative sign? No problem. That just means flipping the whole thing to get the reciprocal. Let's actually see this in action with a simple 3-step method. We're going to solve the incredibly intimidating 16 to the power of -3/2. Okay, step 1. Look at the fraction. The denominator is 2, right? So we take the square root of 16, which gives us 4. Step 2. Take that 4 and cube it, based on our numerator. 4 cubed is 64. Step 3, apply that negative sign to take the reciprocal. Just flip it, so 64 becomes 1 over 64. See? Break it down and the impossible suddenly becomes completely manageable. All right, advancing to level 4, surviving surds and irrationals. Let's start off with rational numbers. Basically, if you can neatly pack a number into a fraction made entirely of whole numbers, like 5/8, for example, you're looking at a rational number. It behaves well. It makes sense. But by contrast, irrational numbers, like pi, they are the messy ones. They can literally never become perfect fractions. Their decimals just go on forever without ever repeating. You just can't contain them neatly. Which brings us straight to surds. These are simply unresolved roots, like the square root of 2, that fall right into that messy, irrational category. And because you just can't get a clean integer out of them, leaving them in their root form as a surd is actually, believe it or not, the most mathematically accurate way to write them. And here we are, the final boss battle, tactics for maximum marks. Okay, here is how you win. First, always show every single stage of your calculation. Examiners reward the process, not just the final answer. Second, check for a negative index immediately, so you don't accidentally forget the reciprocal. Third, if you're comparing indices, make sure to rewrite your numbers so they share the exact same base. And crucially, if you get stuck, just skip it. Move steadily onward and then come back to the tough ones at the end. Do not let one single question drain all your time.
Mastering powers and roots is just a gigantic chunk of the essential knowledge you need for the GCSE number module. Applying these rules methodically and without rushing is absolutely your ticket to a great grade.
So, if this structured explainer helped you level up today, please make sure to hit that like button and subscribe. We want to help you ace every single module, so you definitely don't want to miss our next AQA study guide.
I'm going to leave you with this final thought. Once you stop seeing maths as this dry list of facts and you actually start understanding the why behind the rules, it completely transforms into a logical language you can easily decode. So, what other complex topics could you easily master once you find that underlying logic? Keep questioning, keep practicing, and good luck with your revision.